Okay, before we go into this video, I'm going to give a shout out to my 7th period class. And I'm not going to mention any names, but you know who you are. So anyway, let's do this. Verifying inverses. So what we're going to do is we're going to check to see, to prove whether or not two graphs or two functions are inverses of each other or not. So there are two ways to determine if two functions are inverses of each other. One way we're going to look at graphically first and then algebraically. Simply, here we have two functions and we want to know, are they inverses of each other? So the easy way to do it is pick some points and write their coordinates. So the coordinates of this point, -1, 1. -1, 1. Now, the inverse of this point is going to be 1, -1. So 1, -1. And notice how it fits right on this point. So 1, -1. So these 2 points are definitely inverses. Okay, let's check another one. So this point here, 0, 5. So the inverse point would be 5, 0, which would be this point here. And we could continue this. You kind of get the idea, right? So you would want to check all of the points to make sure they're inverses. So that's how you could verify if two functions are inverses of each other. Or any graph for that matter. They don't have to be functions. Okay, determine if the two functions are inverses by graphing. So we would start by graphing this one. Okay, first of all, it's linear. Okay, so we're going to go ahead and plot the y-intercept, apply the rise over the run, and since I don't have a ruler here, oops, I missed a point here, forgive me. Rise 1, run 3, rise 1, run. I thought it looked kind of weird. Rise 1. See, this is why you use pencil, Edgar. You don't use pen. Because now I can't erase it and it looks all disgustingly, you know, wrong. So anyway, ignore those 2 points. Okay, so there is f of x, function f. Okay, now graphing function g. So we have -2 is our y-intercept. Our slope is 3 over 1. So we're going to rise 3, run 1. Rise 3, run 1. Rise 3, whoops, run 1. Get yourself a straight edge. Line up the points. Okay, now let's find out if these are inverses or not. So the first point here is 0, 2. I'm going to go ahead and write it over here. So f of x has a point 0, 2. So g of x should have a point 2, 0. Is that true? 2, 0. No. Done. Not inverses. No. Not inverses. Because the point 0, 2, the inverse of 0, 2 is 2, 0, and if you go to 2, 0, there's no graph there. They have to match. Okay? Alright, now for the fun part. Algebra. If functions f and g are inverses of each other, then f of g of x equals x, and g of f of x equals x. Huh? Yeah. Well, here's what this is. This is a composition, okay? A composition of functions. And to do a composition of functions, you take one function, in this case, g, and you plug it into f, into function f, where you plug it in where you see an x. Any place you see an x, you're going to plug in function g. So here's function f, here's function g. So we're going to take this function right here, and we're going to plug it into function f everywhere we see an x. So we're going to have 2. Oh, I see an x. Plug it in. Remember, this is called a composition. I should write that down for you. It's called a composition. Like in music, composing, composition. Now, in order for them to be functions, when you compose the two functions, you plug one into the other, and then you simplify this using GEMDOS, you should end up with x as a result. So if I simplify this, I should end up with x. So let's do it. So 2 times a half is 1. So I have 1x. 2 times negative 2 is negative 4. And then bring down the plus 4. Okay, continue to simplify. Negative 4 plus 4 is 0. So x plus 0 is x. So this represents f of g of x. And since it equals x, then we know that g is the inverse of function f. Now, let's do it the other way around, because it says and. So we're going to take function f and plug it into function g. Where? That's right, everywhere we see an x. Okay, so function f, we're going to take this function right here and plug it into function g. So 1/2, there's an x. 2x plus 4 goes in, minus 2. All right. So this is going to be g of f of x. All right, here we go. 1/2 times 2, 1. 1/2 times 4, 2. Canceling those out, we get x. X, x. We did both of them. We get x both times. So are they inverses of each other? Yes, because you simplified both of them and got x's. This will take some time. You will learn it. Don't panic. Okay, here we go. Determine both algebraically and graphically whether or not f and g are inverse functions. So I want to really focus on the algebra right now, okay? So we're going to start off with f of g of x. I know the symbols can be confusing. Just remember that, notice that inside the parentheses for f, is g, function g. So this function right here is going to go into f, function f. Function f is right here. So we start by writing 4, and we see an x, so we plug in g. Everywhere you see an x. So 1/4 x minus 3. Okay, got to finish the function. That was 4 times function g plus 3. Okay, distributing 4 times a 4th is x. 4 times negative 3 is negative 12 plus 3. So we end up with x minus 9. Can I simplify that anymore? No. Did I get what I want for an answer? Did I get x? No. I got x minus 9. So that means that function g is not the inverse of function f. So are they inverses? No. You don't even have to test it the other way. So what I want you to do for tomorrow is I want you to try number 5, and then I will check it and see if you got it. I hope you guys are having a good night. Only 11-minute video tonight.